Alright, so this podcast is going to cover empirical formulas. And empirical formulas can simply be defined as the lowest whole number ratio. So lowest whole number ratio of elements in a compound. So for instance, if we had a compound such as C6H12O6, and we looked at this, we could say the empirical formula of this would be CH2O, because a 6 to 12 to 6 ratio is the same as a 1 to 2 to 1 ratio. Alright? But if we had something like CH3OH, okay, we can rewrite that CH4O. Oops, CH4O. And can we simplify that at all? And the answer is no. So some formulas, the formula is the empirical formula, and others, we can make it the empirical formula by just finding the whole number ratio and making it the simplest, lowest whole number ratio. Alright? So that's what empirical formulas are. As far as solving them, most of what you're going to be doing is calculating empirical formulas. And here's basically the steps. The first step is if given percentages change to grams. So if we knew that something was 50% hydrogen and 50% oxygen, okay, and we do that by finding percent composition, kind of like we did in a previous podcast, we could just assume that we have 100 grams of that compound. And if we have 100 grams of it, and 50% is hydrogen and 50% is oxygen, then it goes to reason, or stands to reason, that 50 grams are hydrogen and 50 grams are oxygen. Okay? So again, if given percentages change to grams. The second thing we're going to do is change grams to moles. Alright, we've done that lots and lots and lots of times. We use the periodic table, we just use the molar mass. Alright, next is we're going to divide by the smallest mole amount. Alright, and then kind of under this, I just say 3a, if half or third, then multiply by 2 or 3. Okay? And that's pretty much it. So here's going to be our example. We might have a problem that says you have, we're just going to do it down here, some kind of compound is 40.92% carbon, and we find that it's 4.58% hydrogen, and the remainder, which is 54.5%, is oxygen. Alright? So that is what we are given. Well, our first step is, if given percentages, change them to grams. Okay? So what I'm simply going to do is, we're just going to assume we have 100 grams of this thing, whatever it happens to be, and I'm going to change 40.92% to grams, and 4.58% to grams, and 54.50% to grams. And again, if we have 100 grams of that, then we're going to have 40.92 grams of carbons, and hydrogen, and so on and so forth. So now what's going to happen is, I'm just going to kind of go over here to the other side, and we're going to set up fenced around problems. So we have 40.92 grams of carbon, and we want to change grams into moles. So we're going to have 12.011 grams to 1 mole. And when we do that math, we're going to come up with something like 3.407 moles. And that's moles of carbon. Alright, likewise we have 4.58 grams of hydrogen. We're going to change grams to moles, so 1 mole of hydrogen weighs 1.0079 grams. When we do that math, we're going to get something like 4.54 moles of hydrogen. And then lastly, we have 54.5 grams of oxygen. Alright, and the molar mass of oxygen is 15.999 grams per mole. When we do that, we find that we get a number that's 3.406 moles of oxygen. Alright, so we've just done step 2, change grams to moles. Last is divide by the smallest mole amount. So our smallest mole amount is really that of oxygen. So I'm going to divide each of these by 3.406. Because right now I do have a ratio, it's just not a really convenient ratio. It's 3.407 moles of carbon to 4.54 moles of hydrogen to 3.406 moles of oxygen. So when we divide by the smallest, we are going to get, hopefully, a simpler ratio. Because all these are going to end up being something to 1. Okay? So my carbon, I'm just going to have running out of room on the side of the screen. So carbon to oxygen becomes 1 to 1. Hydrogen becomes 1.33 to 1. And oxygen obviously becomes 1 because we're dividing by itself. So because we have a third, alright, or approximately a third of something, we really want to multiply each of these things by 3, alright, because we want the smallest whole number ratio. So if I divide each of these by 3, we're going to end up getting 3 moles of carbon for every 4 moles of hydrogen for every 3 moles of oxygen. So what this becomes, formula-wise, is C3H4O3. Alright, and that is my empirical formula. Again, 3 easy steps. If there's percentages, change them to grams. Sometimes you might have a problem that just gives you grams to begin with, so you're just going to change grams to moles, divide by the smallest, and if it's problems that I have come up for you, quiz, test, homework, they are either going to end up being whole numbers, they might be half numbers, if they're all halves, multiply everybody by 2, or if they happen to be thirds, multiply everybody by 3. That is it.